All right, this section has both product rule and quotient rule in it, so let's talk quotient rule now. So if f and g are differentiable at x, differentiable, I'm missing something, aren't I? There it is. And g of x does not equal 0, then the derivative with respect to x of f of x divided by g of x is equal to f prime of x times g of x minus f of x, g prime of x, all over g of x squared. All right, and I know that I can't have a 0 in the denominator, so that's that extra stipulation right there. Here's what this is. We're going to take the derivative of the top times the bottom minus, because it's division, so that's a buddy with minus, minus the top times the derivative of the bottom all over the denominator squared, or the bottom, I guess, is the word we've been using. There it is. If you think about the product rule, we're doing the same kind of thing. The first thing you see is the numerator. Take that derivative first. The bottom comes along for the ride. Minus, because it's division, so minus goes with that. Leave the top alone times the derivative of the second. The numerator of this is exactly the same process that we're doing as the product rule, except the product rule is a plus and this is a minus because it's division. The kicker to this is it's then all over the denominator squared. Straight up denominator, exactly what it is. Okay, I was getting mixed up there. Yes, so my tools. So the denominator is exactly what it is. No derivative associated with that. It's just straight up denominator. All right? Okay, let's do one here. Here's example 2. Find the derivative, of course. And this is just another process you have to know. The quotient rule is just another process. Practice it enough that you'll get it down. Now for this problem, h of x is equal to x squared plus 3x plus 4 over that x squared minus 1. Yeah, if you can factor in real life, then do it. You can't in this particular problem. The only way to take this derivative is going to be the quotient rule. Well, lucky enough we just learned it, right? So let's practice this bad boy. So the derivative of the top, right, is going to be 2x plus 3. That's just the power rule. Bring the 2 in front. And then that's my constant. That's a 0. So the derivative of the top times the bottom, I'm not touching it, minus the top all by itself times the derivative of the bottom. So then the derivative of this one is 2x all over the denominator, exactly how it sits, squared. Do you see that? You see what's going on? So the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, here we go. Now we algebra this. So h prime of x, I'm going to FOIL that, is going to be 2x cubed minus 2x plus a 3x squared minus 3. Now with this one, this is a monomial, right? Because this is a monomial, I'm going to distribute this monomial. But in lieu of having to do double here, I'm going to make that a plus and bring this over as a negative. And I'm going to distribute a negative 2x just so that I can do it all at one time. All right? So when I do this distribution, I'm going to make that a plus, make that a minus, a negative. Then I'm going to distribute that negative 2x. That way I don't have to do double. So negative 2x cubed minus a 6x squared minus 8x all over x squared minus 1 squared. Now we just clean it up. A plus 2x cubed and a minus 2x cubed. Wow, that's interesting. I've got a couple of like terms with my squares. I've got some x's right here to look at, and then I've just got that number. Okay. It's good to see what I'm working with. So I've got 3x squared. Still writing the derivative notation. You can't lose it. It's saying what this answer is. I've got a negative 3x squared minus a 10x minus 3 all over x squared minus 1 squared. All right. If you can simplify, then we want to try to simplify. If at all possible, then we want to look at that. So let's see if we can. Sometimes it makes it nice because you want to see if there's some x squared minus 1 that you can cancel out, right? Or an x plus 1, x minus 1 situation. So if I factor out a negative, I'm left with 3x squared plus 10x plus 3. Oh, ladies and gentlemen, I think we can factor that numerator. I don't know if it's really going to help us. But I've got a 3x and an x. If I make this a 3 and a 1, we just did it, didn't we? So if I check my outsides, there's my 9 plus 1 is 10. Okay. You can, the moral of the story is you always want to simplify a rational expression. So simplify if you can. In this instance, we factored and you couldn't simplify. So sometimes my math lab will say, oh, well, then you could have just left it back up here then, right? However, if it's simplified, you can write it like that, and that just makes it easier. I will say, as we move forward in this course and in next chapter, when we start graphing these and finding critical values, you're going to have to factor. So you might as well get in the habit of doing it now, is the moral of that story. All right? Okay. I know there's not much room down here, but check this out. Example 2b. F of x is equal to a 2x to the negative 3. Now, I'm not going to go try to do the quotient rule on this. That's crazy. We're not even going to do it to practice, just because that's asinine. This is the power rule. Take that exponent, move it in front, gives me a negative 6, and don't forget you're subtracting 1, so that's to the negative 4. Even if it tells you in your homework to try to do something with a quotient rule on that, don't do that. That just gets too crazy. All right? Okay.